Hi dear students. Last class we discussed about the queue. You know about queue. Queue already see it is a linear data structure. Okay, already you know this. What is queue? Queue means it is also a collection of elements which has. Okay, so yeah, see it is a collection of elements. It is a collection of elements. You know that here also the element can be deleted. Element can be inserted. Okay, inserted from rear end and you can delete it from front end. Okay, the element can be inserted from rear end and deleted from front end. Already you know this. Then see, for example, I am inserting 10 from rear end. You can insert, means rear means top. From top up you can insert then 20, 30, then 40. Then if you want to delete the element, how to delete the element? From front end. From front, first deleted 10 will be deleted, after that 20, after that 30, after that 40 will be deleted. Okay, this is called queue. Then what is queue? Queue is it is a linear data structure, okay, in which the item can be inserted from rear end and deleted from front end. Okay, that is called queue. Already you know this. Then okay, then you know about the, it is what's on the principle of FIFO. FIFO means what? FIFO means first in, first out. Okay, first in, first out. Okay, last class you discuss about this. First in, first out. For example, for where you have to use queue, queue can be used when a printer server application. You know printer. Okay, when you given any pages. Okay, one by one pages will be come out. First page ಯಾವುದು ಪ್ರಿಂಟ್ ಆಗುತ್ತೆ ಅದು ಫಸ್ಟ್ ಹೊರಗೆ ಬರುತ್ತೆ. ಫಸ್ಟ್ ಇನ್ ಫಸ್ಟ್ ಔಟ್. ಓಕೆ, ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ we discuss about these. Okay, printer server application in operating system also. In operating system how to use already you know. Okay, one by one the operating system it execute the processes one by one. That is also one of the example for a queue. Okay, sending a SMS through one computer to another computer. Okay, for example we are chatting with others. First which SMS, whatever SMS you can send first, that will be goes to, that will reach to destination first. Okay, next when you sending hello, that will goes to next. Okay, like this sequentially the message will be goes. Okay, how it is possible? Because of queue. In queue also used in computer network. Computer network means you can sending a SMS or messages from one computer to another computer. Okay, there also you have to use this queue concept. Okay, last class we discussed about the applications. Okay, then now the last class we discussed about the stack. The difference between stack and queue. Okay, what is the difference between stack and queue? You know, stack means it is it is also linear data structure. It is also linear data structure. Both are linear data structure. But here in a stack, okay, but in a stack here item can be inserted and deleted at one end only, one end. Okay, one end. But in queue the item can be inserted at rear end from top and the item can be deleted from front end from bottom. Okay, this is the difference. It is works on the principle of a FIFO. This is works on the principle of a FIFO. Okay, last class we discussed about this. Okay, difference between stack and queue. Okay, then the last class we discussed about the operations on queue. What are the operations? What are the operations on queue? The first operation is a queue means it is a one empty queue. If you want to insert the element, okay, must and should it creates a new queue. Okay, then second one is the enq. Second, the best operation enq. What is the use of this operation? Enq means you can the process of inserting elements, okay, into the queue. That process is called enq. Okay, enq. But in a stack you have a push operation. Okay, but then the third one dq, the process of deleting the elements. The process of deleting the element from front end. Deleting the element from front end, that is called dq. Okay, front end, that is called dq. Okay, that is also main operation. Then you have a fourth one is size. Size means how many elements are in Q. It indicates the how many elements now in this. Okay, how many elements? There are 4 elements. Okay, last class these operations already you studied. Okay, this is what is about Q. The Q will be works on the principle of a FIFO. Okay, this much already you studied. The next we can study about the memory representation. See, the memory representation of Q. Already you know about the memory representation of a stack. Same like here also you have a memory representation of Q. 3 marks or 5 marks question will be asked to explain the memory representation of a Q. How the elements are stored. Memory representation means how the elements are stored in a Q. Okay, see how the elements are stored in a Q. First, this is one Q. Okay, I am inserting how many elements? Okay, 4 elements I am inserting. Okay, one by one I am inserting how many elements? 4 elements. Okay, see, so first how to insert an element? You know it is a Q. It is a Q of n elements. How to insert an element? You know Q will be, you can insert element from rear end. First I am inserting first I am inserting the 10. Okay, after that the first, you see, when you have empty means, empty Q means, first you have to remember, if you have a empty Q, there is no element in this. If you have a empty Q means that time the front equal to -1. Front equal to -1 means, see, the Q will be empty. Okay, Q will be empty. Q is underflow. Okay, Q is empty means what? That process, that situation is called underflow. Okay, front equal to -1. Okay, then when you inserting the element 10, the front will becomes to f equal to 0. -1 next the next value is 0. Okay, when you inserting 10, okay, that front comes to 0. Q of front, Q of 0. In Q of 0, 10 will be stored. Then I am inserting 20. Then front equal to incremented 1. That 10 will be in Q of 1, 20 will be stored. In that 30, in Q of 2, 30 will be stored. In Q of 3, 40 will be stored. Okay, now the Q will be full. Okay, the Q will be full. Okay, that situation is called, okay, overflow. That situation is called a overflow. Okay, one thing you have to remember, if the condition front equal to -1, if condition front equal to -1, that situation is called the Q is empty or underflow. Okay, when rear equal to n-1, this situation is this condition. If condition here equal to n-1, this situation is called a overflow. Overflow means the Q is full. The Q is full. Okay, for example, it's ಇದ್ರದ್ದು ಸೈಜ್ ಎಷ್ಟಿದೆಯಪ್ಪ, ಓನ್ಲಿ ಯು ಕ್ಯಾನ್ ಇನ್ಸರ್ಟ್ 4 ಎಲಿಮೆಂಟ್. ದಿಸ್ ಕ್ಯೂ ಸೈಜ್ ಈಸ್ 4. ಫುಲ್ ಆಯ್ತಪ್ಪ ಅಂದರೆ ದ್ಯಾಟ್ ಕಂಡೀಷನ್ಗೆ ಏನಂತಾರೆ, ಓವರ್ಫ್ಲೋ ಅಂತಾರೆ. ಕಂಡೀಷನ್ ಏನಪ್ಪ ಅದರದ್ದು, ರಿಯರ್ ಈಕ್ವಲ್ ಟು n-1. ಎನ್ ಅಂದರೆ ಎಷ್ಟು ನಾವು ಇಲ್ಲಿ ಎಲಿಮೆಂಟು, ಸಿ, ಎನ್ ಅಂದರೆ 4 ಎಲಿಮೆಂಟ್ಸ್. 4 - 1 ಹೌ ಮಚ್, 4 - 1 ಎಷ್ಟು, 4 - 1 means 3. 3 means 3, Q of 3. In Q of 3 40 will be stored. Got it? This is a memory representation of a Q. In examination, if they ask you, you can write the Q. It has n elements. Okay. Here the process of inserting the elements at the rear end. Okay. Then that situation that is called NQ. The process of deleting the element at front end, that process is called DQ. Okay, if front equal to -1, if condition front equal to -1, that situation is called okay, underflow. If rear equal to n-1, that situation is called overflow. Okay, overflow means Q is full. Okay, then I want to delete the element. First ಯಾವುದು ಡಿಲೀಟ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ, 40 will be deleted. First 10 will be deleted. First 10 ಡಿಲೀಟ್ ಆಗುತ್ತೆ ಇಲ್ಲಿ ಕ್ಯೂದಲ್ಲಿ. ಓಕೆ, ದೆನ್ 10 ಡಿಲೀಟ್ ಆಯಿತು. ದೆನ್ ಅವಾಗ ರಿಯರು, ಸಿ, 10 will be deleted. ಫಸ್ಟ್ ಟೈಮ್ ರಿಯರು ಮತ್ತು 2 -1 ಇರ್ತದೆ. rear. Next 20 will be deleted, then 30 will be deleted, and 40 will be deleted. 40 will be deleted. Okay, got it? Like this it will be deleted. This is a memory representation of a queue. Okay, this you have to remember. It's very easy process. In a stack you have only one end, but in queue you have a two end. Okay, you can insert element from a top, and here you can delete the element from bottom. Got it? This much you have to remember. Then the next one is what are the types of queues? There are in examination 5 marks question will be asked. Explain the types of queues. Explain first one in that simple queue. What is simple queue? Simple queue, nothing. This is a simple queue. This is an example for simple queue. Here you can insert the element from rear end and delete the element from front end. Okay, that is nothing but simple queue. Okay, this is you have to write this. You have to write a definition and write this diagram. This diagram. Okay, this diagram. Simple queue. Simple queue, nothing but queue. Definition. You can write queue definition. Simple queue means it is a process of inserting element at rear end and deleting the element from front end. Okay, this is you have to remember. Then what is circular queue? Circular. It is in circular manner. This queue will be in a circular manner. See, for example, this is circular queue. Okay, this is a circular queue. Here I am inserting the first 10, 20, 30, then 40. 10 in queue of 0. This is in queue of 1, in queue of 2, queue of. See, this is see the circular queue. It is in treated as a circular. In this, the last node, it follows the first node. Okay, the last node of a queue, it follows first node. Okay, for example, ನಾನು first 10 delete ಮಾಡ್ತೀನಿ. 10 delete ಮಾಡಿದ ತಕ್ಷಣ ಅಲ್ಲಿ ಯಾವ ಸ್ಟೋರ್ ಬರುತ್ತೆ, ಸ್ಟೋರ್ ಆಗುತ್ತೆ. 40 will be stored here. Okay, 40 will be stored here. Okay, when you deleting a 10, okay, automatically the 40 will be stored here. This is called circular queue. Okay, it is a circular queue. It is treated as a circular. Okay, in this the last node follows the first node. First node is really 10, last node is really 40. The last node it follows a first node. Okay, that is called a circular queue. Then the next one is a priority queue. What is priority? Priority queue means what? Priority means depends on its priority. Depends on its priority. Depends on its preferences. You can insert and delete element. Okay, not like ನಾನು ಹೇಳ್ತೇನೆ ನಿಮಗೆ. Okay, insert from here, ಇಲ್ಲಿಂದ insert ಮಾಡಬೇಕು, then ಇಲ್ಲಿಂದ delete ಮಾಡಬೇಕು one by one. But in a priority queue, depends on its priority, you can insert and delete the element. You can insert the element directly here in middle. Okay, you can delete the element. Okay, you can delete the element, any middle element you can delete it in a priority queue, but in degree level you can study it. Okay, in degree level you can study about this priority queue. Okay, now you have a definition only. What is priority queue? Priority queue means the queue. Okay, the elements can be inserted and deleted, depends on its preference. Okay, depends on its preference or depends on its priority. Okay, that is called a priority queue. Okay, the last one is a double-ended queue. Double-ended queue means, see, this is the double-ended queue. See, this is double-ended. For example, I am writing the 10. This is 20. This is one queue. This is queue of 0. This is queue of 1. So see, this is called insertion, deletion. This is called insertion, deletion. See, what is double-ended queue? What is double-ended queue? Double-ended queue means the insertion and deletion takes place at both ends. Both ends. Okay, both ends ನೀವು insertion ಇಲ್ಲಿಂದ ಮಾಡಬಹುದು, delete ಇಲ್ಲಿಂದ ಮಾಡಬಹುದು. ಬಟ್ ಸಿಂಪಲ್ ಕ್ಯೂದಲ್ಲಿ ಹಂಗಲ್ಲ. ಸಿಂಪಲ್ ಕ್ಯೂದಲ್ಲಿ ಇನ್ಸರ್ಷನ್ ಟಾಪ್ ಇಂದ ಮಾಡಬೇಕು, ಡಿಲೀಷನ್ ಮಾಡಿತ್ತಂದ್ರೆ ಫ್ರಂಟ್ ಇಂದ ಮಾಡಬೇಕು. ಬಟ್ ಇನ್ ಸರ್ಕ್ಯುಲರ್ ಕ್ಯೂ, ಇನ್ ಡಬಲ್ ಎಂಡೆಡ್ ಕ್ಯೂ, what you have to remember, insertion and deletion, okay, takes place at both ends. both ends. Okay, now ನೀವು ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಇನ್ಸರ್ಷನ್ ಇಲ್ಲಿಂದ ಮಾಡ್ಬೋದು, ಇಲ್ಲಿಂದನೇ ಡಿಲೀಟ್ ಮಾಡ್ಬೋದು. Got it? Okay, this is called double-ended queue. Just they are asking you definitions. Definitions. Explain the types of queue or mention the types of queue. There are 4 types of queue: simple queue, circular queue, priority queue, then double-ended queue. Okay, these you have to remember. Okay, then today class you have to you know about the memory representation of queue, then types of queue. Okay, already this is asked for so many times in examination. Okay, these types of queue. Okay, this much you have to remember. Next class we discuss about the algorithm for a queue. Okay, this is about a memory representation of queue. Thank you.